So again, this is verifying trig identities, usually called trig proofs. So you probably can look up extra stuff on YouTube if you need extra practice or you need extra instruction. If you look up trig proofs, that's normally how they're listed. But it probably would still pull it up if it was called trig identities. Okay, so the hints to solve this. This is very similar to what you did at the end of the last section. So at the end of the last section, we were changing stuff to sines and cosines and that kind of stuff. That's what we're doing here. But now it's going to be equal to something. Okay, so I'm telling you what the answer is, and you got to tell me how to get to that answer. So the hints to solve. Learn the fundamental functions. So if I say what is tangent, it would be really nice if you could say sine over cosine. Okay, I'm not telling you you have to memorize it. It's just going to make it a lot easier where you don't have to look at that sheet every single time. Because the more you look at that sheet, the more overwhelming it is because you're looking at all that stuff rather than just the thing you need. So if you know that sine squared plus cosine squared equals 1, that's good. If you know that the reciprocal of cosine is secant, if you can pull that stuff out of your head, it'll make these go a lot smoother. Okay? But I'm not requiring you to memorize that sheet. Next, try to rewrite the more complicated side. Okay? So we're going to look at it, and we're going to decide which side looks harder, and that's the side we're going to work with, which is super counterintuitive, but we're making it simpler. We're trying to fix it, okay? Rewrites in sines and cosines, I actually would recommend doing that last, as I talked about last class. We want to factor, let's say if possible, factor if possible, okay? That's that algebra step that I was talking about. You want to do algebra. You want to figure out the normal stuff, distribute, factor, all that stuff. And then this is the new step. If you see something that looks like this, 1 plus sine, or 1 plus cosine, or cosine plus 1. Something with a cosine or a cosecant and a 1, then we want to multiply that by its conjugate. Okay? If you don't know what the word conjugate means, it's the same thing with a different symbol. So if we see a 1 plus sine, you're going to multiply by a 1 minus sine. Okay? What that's going to do is that's going to turn it into a Pythagorean identity. If I multiply 1 plus sine by 1 minus sine, that's going to do FLA, the F in the L of the FLA, which will turn into 1 minus sine squared, which goes straight to our Pythagorean identity. Okay, so those are a couple hints. Next class, I'll have that written again, just so we can get that in our heads. But it just takes practice. So let's start practicing. Okay, so looking at this first one, our first thing is looking at the more complicated side. What side is more complicated? The right side. Okay? So what I said just a second ago, I said I don't like the factor if possible. I like that to be up above. So I want to do algebra to this side. What would I do in algebra class if I saw something outside of parentheses? I would distribute it. So go ahead and distribute this into these. And you can't multiply them times each other, so just write them next to each other. So cosecant, cosine, plus cosecant, sine.
Does it matter what order we put them in?
Does not, because you can multiply in any order, right? Okay, so we did the algebra. Okay, so let's say that one, the algebra step, and if you want to write that as just algebra in general. Okay, we wrote that, and now if there's nothing else to do, just change the sines and cosines. There's nothing else to do. We can't combine these. They're not like terms. So if we change everything to sines and cosines, cosecant, if we look at our sheet, or if you know it, the reciprocal of cosecant is sine. And I get in the habit of not putting my thetas, and that's fine. I'm okay with you even putting the result without a theta. Okay, because we're just writing it so much. So sine, 1 over sine, cosine's already cosine. 1 over sine, sine is already sine. Okay, I'm seeing that it looks a little bit more like a common denominator, but I don't know if I want to do that yet. I could combine those But over on the left side, we have two things, okay? So remember, this is our answer. This is what we're going towards. So if I made these common denominators and then put them together, I'd have one thing, and I want two things. Okay, so we're always comparing. Yeah?
How come you don't do anything with the cosine or the sine?
Because they're already sines and cosines.
I need to like that's what you want to get into.
Because that's what our hints say, and that's what our directions said last class. Because sines and cosines is usually that's the basic ones, right? You want to get everything back to the basics. That's what everything kind of compares to. Okay, so I don't want to combine these because over here I have a plus between them. I have two things. But what I can do is I can multiply these and get cosine over sine. And right here I can get sine over sine. So I'm just going to multiply those. So cosine over sine. And sine over sine. If you know your sheet, hopefully you're seeing this actually turn into the left side right now. If you look at that first fraction, what is that first fraction the exact same thing as? Cosine over sine turns into cotangent. And what is sine over sine? 1. So cotangent of theta plus 1 equals cotangent of theta plus 1. There we go. That's what we're doing. We're trying to make the sides look like each other. Okay? So, like I said, with extra practice, you'll start seeing that even up here. Even up here, I would see that these are reciprocals, right? Last class I said when you multiply reciprocals, they turn into a 1 automatically. So you could have just turned that into a 1 and not even dealt with this side. That would have just become a 1, and then you just had to figure out how to turn this to a cotangent. Okay? Let's try another one. Which side looks more complicated?
First side.
The left one, okay? So we want to turn, we can't do any algebra, there's no distributing, factoring, anything like that. So let's just change everything to sines and cosines. Yeah, Pierce. On this one, something over itself equals 1. The left side was already the left side. Okay, so the left side of this is more complicated, so we're going to ignore that cosine theta for now, and I'm going to change everything to sines and cosines. Hopefully you know from memory, cotangent is cosine over sine. So this looks like 1 on your quiz. And on the bottom, cosecant changes to 1 over sine, multiplying by the reciprocal. So we're going to multiply by the reciprocal, cosine over sine, multiplied by sine over 1. Because we're dividing by a fraction, my signs cancel, and you can see that this side now says cosine of theta, and that equals our proof of cosine of theta.
So we turn that cotangent one to cosine over sine because that's the only one that.
Because that's what we do. When there's no distributing or anything like that, we just change stuff to sines and cosines and hope for the best.
Okay.
And a lot of times it'll work itself out like that. Okay. Which side looks more complicated? They both look pretty complicated, right. I think that the right side looks more complicated because there's more circular functions. There's a cotangent and a tangent, okay? The left side looks complicated because it's a fraction, but I just think because there's more of these things that are the things that confuse us, this is the harder side, okay? I also know, because of practice, I haven't done this in a year, but because of practice, I know that if I distribute this, these are reciprocals. That's going to turn into a 1. That's going to help me out. Okay, that's one of those things that you might recognize. Okay, so I'm going to do the right side. You could also see the left side and recognize something too, by the way. I'll talk about that in a second. So tangent squared theta plus tangent squared theta cotangent squared theta. So those are reciprocals. They turn into a 1. If you can't remember that those are reciprocals, you'd end up changing the sines and cosines and seeing that stuff cancels anyway, because there'd be a sine over a sine and a cosine over a cosine. Okay? So that is, that's the wrong color. That is tangent squared theta plus a 1. Okay? There's nothing else really to do. Anybody know what we could do? So we could do that. One thing that I didn't have written on my hints is anytime you see something squared, just check your Pythagorean identities. Tangent squared plus 1, does that turn into anything? Yes. So this equals secant squared. Okay? So anytime you see something squared, especially if there's a 1 next to it, check your Pythagorean identities. So secant squared thing. Okay? So this is what I was saying earlier. You might have seen this and thought Pythagorean identity. You can change that to a cosine if you want, but right now I want you only working with one side so that you're not as overwhelmed. Okay, now let's change them to sines and cosines. Hunter, now what does this change to? 1 over cosine, but it's squared, so you got to write squared as well. So 1 over cosine squared. Okay, and we always want to keep looking at our side. So our other side, we got a 1 over something and we got a 1 over something, so we're almost there. We see something squared, which I told you if we see something squared, let's look at our Pythagorean identities. What can cosine squared turn into?
A 1 or a sine?
1 minus sine squared.
1 minus sine squared. I'm going to pull that up because I don't have it up here for you. Okay, so right there, I still have it written from last class. All we did was we manipulated it a little bit. We subtracted sine from both sides, and it says cosine squared is 1 minus sine squared now. Okay, so again, I told you, you can do this for all 3 of these. You can manipulate them and make them look however, and you can write that all over your sheet. So you don't have to think about that if you want. Yeah, it's just solving an equation. Right there, we were just solving for cosine, just like algebraically we would as with numbers.
So,
Okay, so cosine is the exact same thing as 1 minus sine squared theta, which is exactly what we want it to look like. So there's our proof. 1 over 1 minus sine squared theta. Okay, you are also allowed to manipulate both sides of this. So if you wanted to, when you got to here, instead of doing this step, you could have changed this to 1 over cosine and then had the sides equal. I just like staying with one side if possible. Okay? So again, one of those things we'll start recognizing as we go deeper and deeper into this. That's why we're going to do days worth of practice on this. Okay? Which side looks more complicated?
the left side.
I think the left side does, because it's got more of those circular functions and it's a fraction. Okay? So what can we do? So there is something algebraically we can do. If I said 2x plus 4, don't write this because we're going to write underneath it anyway. If I give you this, how could you simplify that?
X plus 2.
You basically what you're going to do is you would put a 2 underneath each and then simplify, right? So what I'm going to do here is I'm going to break this up, break this kind of, not in half up here, and put sine over cosine underneath each piece. So tangent theta over sine cosine minus cotangent theta over sine cosine. Also, the other thing about these is there's probably multiple methods to get to the answer. So it could be that there's a shorter method, but this still proves it, and that's what we're trying to do. Okay, so there's really nothing else to do. That was kind of an algebra step, kind of splitting it up. So there's really nothing else to do. Let's change our tangent to sine over cosine, and let's change our cotangent to cosine over sine. So sine over cosine over sine cosine minus cosine over sine sine cosine. Okay, it looks like a lot, but because we have some signs on the top and the bottom and all that stuff, it probably will start canceling out a little bit. The one thing I'm going to do is I'm going to take these and write them out front, because if there's something on the top, you can put it out front instead. Going back to regular algebra, if I have something like x over 7, that's the same thing as 1/7 x. You can take the top thing and put it out front or out on the end of it. So we're going to take those things and write them out front. So sine over cosine multiplied by 1 over sine cosine minus cosine over sine multiplied by 1 sine cosine. And we can cancel some stuff out. What we can cancel out? Well, we got a sine on the top and we got a sine on the bottom. We got a cosine on the top and a cosine on the bottom. So what do I have now?
1 over cosine minus 1 over sine.
Not just cosine, cosine squared, because there were two of them. So 1 over cosine squared minus 1 over sine squared.
Why did you square
Because cosine times cosine equals cosine squared. Because you're multiplying the bottom.
it? Oh.
Okay, so remember, we always want to look at our other side. It looks like we're getting less complicated, which is good. And we look up here, and we want to end without sines and cosines. How do I change a 1 over cosine to a secant? Yeah, it's just the reciprocal of it. So it literally just changes. So that cosine turns to a secant squared, minus the sine on the bottom turns to a cosecant squared, equals what we want. Secant squared minus cosecant squared. Yes?
Why isn't it plus, like secant, it put a secant plus cosecant at the top?
Oh,
Why isn't it?
good catch. That actually is a typo that I made. This should be a minus. Good catch. I change that every year, but when I go through and clear the slides, it erases my white out. And every year, somebody calls me out on that. Okay, so again, I know that looks like a lot. It is a lot. But as your brain starts seeing this stuff differently and starts recognizing that things can turn into other things, you'll start recognizing this. It's not impossible. It is hard, but it's not impossible. Okay, next one. This is a hint that we haven't talked about. So the very last hint that I had written down, it said if you see a 1 minus something not squared, you multiply by the conjugate. So 1 minus sine, that's not squared. So we can't go to our Pythagorean identities. If it was squared, we go straight to our Pythagorean identities and start changing stuff. It's not squared. So first thing I'm going to say is I'm going to choose this side. It really doesn't matter which side you do. They both look pretty complicated. But this one has two parts on the bottom of the fraction, which I think is a little bit more complicated. Okay? So what I'm going to do is I'm going to multiply by the conjugate. So 1 plus sine on the top and 1 plus sine on the bottom. Okay, on the top, we're going to FOIL. No, on the top we're going to distribute. On the bottom we're going to FOIL. So we're going to distribute this in.
Now you're saying
Okay, so on the top, we get cosine plus sine over cosine. Actually, okay, we'll do it. Okay, on the bottom, we're going to FOIL that.
Why?
Because we have a binomial multiplied by a binomial.
Why don't you FOIL the top? Why do you FOIL the opposite side?
What are you talking about, the distributing? So we're distributing. Remember, FOILing is just distributing twice, right? So usually one of my rules that I actually didn't follow this time is on the top, we normally don't distribute. Because on the top, we normally want to factor that anyway, because we're going to cross stuff out later. On the bottom, we do. So right here, I actually am going to factor that cosine back out, but we'll hold off on that for now. Okay, what about the bottom? The bottom should be something that should immediately tell us to look somewhere on our paper. On the bottom, we have squared with a 1. What can we change that to? That turns to a cosine. So I have cosine plus sine cosine over, I'm probably right in the middle of that dot, equals cosine squared. Okay? So on the top, we have a cosine in each part. We actually have a cosine in every part. Okay? So we can factor a cosine out of the top.
It's cosine on the bottom.
What?
Why do you have cosine on the bottom when it was sine up there?
Because of this right here. That. We can use that. We can manipulate it to this and turn it into cosine.
Okay.
1 minus sine is the same thing as cosine. So I'm factoring a cosine out right here. And so that is 1 plus sine equals, with a cosine squared on the bottom, I can cancel out 1 cosine from the top and 1 cosine from the bottom. And if you see, we are getting to exactly what is on the right side there, with 1 plus sine theta over cosine theta equals 1 plus sine theta over cosine theta. Okay, so it ends up working itself out. Remember, I have given you the answers. You are just telling me how to get to the answer. Just for the record, I worked out the other side last year. I multiplied by 1 minus sine and 1 minus sine to the conjugate of this, and it works out just the same. So if you accidentally choose the not as hard side or a different side, it will still work out. It just might work out a little differently. So this is last year's, okay? So exactly the same type of process, you just multiply by the conjugate. Okay, we're almost done. Here's a big one. Okay, so this one's going to be a little bit bigger. It's going to take a little bit more of what you should know from algebra. Okay? We're going to talk about difference of squares, which you've learned. Okay? This is one of the few where you're actually, I am recommending you adjust both sides. Both sides of that look very challenging, so both sides are going to be dealt with. But I'm going to deal with the right side first. And the reason I'm dealing with the right side first is because there's 3 parts on the top, I guess. But we're going to do both. Okay? So first, let's deal with the right side. The right side on the top, hopefully you recognize that there's 3 parts. And we have something in algebra we do with something with 3 parts.
Oh.
What do we do? We do asterisks.
Wow, that's a wow.
Okay, look right here, look right here. This is squared, 1, and none. Okay, so let's just rewrite it. So sine squared theta plus 2 sine theta plus 1 over cosine squared. So we're going to do asterisks on that. So a 1 goes in the top. A 2 goes in the bottom. A 1 and a 1 go here. What multiplies to go 1 that adds to get 2? 1 and 1. Okay? So on the top of this becomes sine plus 1 sine plus 1. That's actually a perfect square trinomial. But you weren't told that, so you can't assume that. Okay, on the bottom, I have cosine squared theta still. Anybody know what I would recommend here? Yeah?
Since there's, since it's like sine plus something. Oh wait, never mind.
There's a cosine.
So there's a cosine squared, so Pythagorean identities. So what you were thinking is the conjugate thing we just did, but that looks insanely hard. So I'm going to try that on my last move if something else doesn't work. Okay? Because if you did the conjugates here, then you would have to do foiling and then foiling again. Like you'd have to do multiple. So instead, let's just change the bottom to 1 minus sine squared. So on the top, we have a sine plus 1, sine plus 1. I just forgot the rest of that word. Okay? Sine plus 1, sine plus 1. On the bottom, we have a 1 minus sine squared. Okay, this is where you're going to have to pull something out of your memory. On the bottom there, that is something called difference of squares. Okay? Difference of squares we worked with before. A plus b, a minus b. Like if I had x squared minus 25, you can turn that into x plus 5, x minus 5. Okay? So I have two things that are being squared on the bottom. I can change that to 1 plus sine, 1 minus sine. On the top, I still have 1 plus sine, and I switched the order for a reason. And on the bottom, or on the top, I still have 1 plus sine right here as well. Okay, so we can cross these out. One plus sine, 1 minus sine. Okay, there's nothing else I can think to do there. You might think multiply by the conjugate, but that's exactly what we just did. If you multiply by the conjugate, you're doing backward steps of what we already did. We took the conjugate out just now. Yeah, it doesn't look very good, does it? Okay, so let's go to the other side and change some things. See if they end up looking the same. Okay, so what can we do on the other side? We can't do anything on the other side, so let's just change them. Change everything to sines and cosines. So 1 over cosine. Okay, we're changing everything to sines and cosines here. It's just a big puzzle. There's actually no math in this, really.
Well, why are we doing it even?
You're right.
Yeah, there's no
Very
math.
cool.
It's a big puzzle. It's a logic puzzle, which is math. Anyway. All right, so I wrote that wrong. Right here. Stick with me. We're almost done. Okay, what do you notice about all of those fractions?
They're all blue.
They're all the same except for the.
What's on the bottom of every single one of them? So we can take the whole thing and multiply it by a cosine, and it gets rid of all our fractions.
Simplify into our problem. Wow. Why did we do this first?
Because it wouldn't look like the other side yet.
That's so right, Mr. Megison. I'm so happy you're paying attention to my class.
1 plus sine over 1 plus sine, no, 1 minus sine. I wrote it wrong. Okay, 1 minus sine, 1 minus sine. And there we go. We have sides that equal each other.
They're on the same level. Wait, is it?
Okay, so you could have started off.
Oh my gosh.
Hey, there's an easier way.
I don't care.
No, I'm serious.
I don't care.
That's a much easier way. So let me talk to you about it. Hold on.
You know what I just realized,
Listen.
Megson?
Listen.
You know what I realized?
What?
If you get one side, then you already know the other.
What do you mean?
The answer is like
I've given you the
the
answer.
homework is due to the work.
Oh.
Okay, so why was this side harder? Because we had to asterisk and we had to do difference of squares. So if I go here and I change everything to sines and cosines and I get to this, Jack, what did you say that we do when we see a 1 minus sine? We can multiply by the conjugate. If I multiply by the conjugate, you end up getting that. So there is an easier way. Sometimes you do the hard method and then figure out that there's an easier way. Okay? But that's what practice will get you. It'll get you to that easier way. Yes?
Technically, don't you only have to do one side? Because if you get one side, you do the other.
Yes, that's what I'm saying. So if you did this side, that's fine, but you would have to continue and then you get here. Here, I can't see where to continue on this. What you would have to do to continue to break this down to make it look like that is you would have to think, well, what if I put a cosine under everything? So if I put a cosine under this, it turns into a tangent. If I put a cosine under the 1, it turns into a secant.
Okay.
But that's a hard step to see. So sometimes you have to adjust both sides a little bit. Okay, so what I'm going to hand you for homework, it is 9 questions.
Wait, doing them right now.